Hi everyone, this is Miss Mayorga. In this video, I'm going to be going over lesson 24. I know this was a lesson that we did a little while ago, and I got super busy and I never put the video together. So here it is. All right, so lesson 24, functions. For this lesson, we completed bubbles 1 through 10. We skipped, for bubble 6, we did A, B, and C. We skipped D. For bubble 7, we skipped that, and then bubble 10 is the one that I graded. Bubble 11 is an optional challenge. All right, let's go ahead and get started. This lesson, we're going over functions, so make sure you're logged in, ready to go. Continue. I believe bubble 2 is a video, so go ahead and pause my video, watch this video, and then come back. All right, welcome back. Bubble 3, calling functions. Functions let you build your own blocks and decide what code goes inside of them. This program has already created 2 functions, but only one of them is being called. Do this. Call the second function to reveal the full image. Use the function that is being called as a guide. Tip, just as with all other blocks, spelling and capitalization are important here. Okay, so let's see what's going on. If my computer lets me, what's going on? There we go. They have called this function draw sky. And if we look at the function called draw sky, there's a no strict block, background, fill color, and ellipse. So that's what we see, the background and the fill color ellipse, yellow ellipse. Now we need to call the second function, balloons, draw balloons. So I'm assuming these are balloons. Let's go ahead and call the second function. Go to your functions block, grab the little one, the little block, drop it right underneath, and rename it so that it matches. Draw balloons, draw balloons. And now when we run our program, the balloons appear. All right, so remember, you have to define a function and call the function. All right, so step 1 or step 2, I guess it doesn't matter what order you do it in, but you have to do both. You have to define the function, call the function. That way the computer knows that you want the computer to use the function that you created. Finish. Okay. Reordering code. Placing code inside functions makes it easy to read and make changes to. Good names for functions indicate what your program is doing to a reader. You can call your functions in a different order to quickly make significant changes to how your program runs. Do this. This program has already created 4 functions that draws parts of a scene. Unfortunately, it's not coming out right. Read the 4 functions to know what they do. Call the functions in an order that draws a scene in the way that looks best to you. Okay, so let's see what 4 functions we have. We have draw background, draw trees, draw clouds, and draw fence. Right, so it looks like we're drawing different parts of a scene. What should we draw first? Remember, the order matters. Whatever gets called first is going to appear, and then everything else appears on top of it. So think about what you want the back layer to be. I hope you said background. All right, so let's go ahead and grab this up here, and let's say draw background. So now we should see our background appear. Blue background with a green rectangle that looks like grass. All right, now we've got the background. Now, what should we draw next? Trees, clouds, or fence? All right, I'm going to go with clouds. I guess I'll just go with trees. Let's see what happens. Draw trees. There we go, there we go. I'm just going to go down the list. Now I'm going to call draw clouds. Wait, right there. Draw clouds. Uh-oh. The clouds are covering the trees. If you like that, you can keep it that way. But I think I want the clouds to go first so that the trees don't get covered. So I just dragged my block and I rearranged it. Just put it right up there. Now the clouds, first the background, then the clouds, and then the trees. That's why the trees are on top of the clouds. And the last thing I'm going to call is draw fence. There you go. Now if you want the trees to go in front of the fence, you just move your draw fence block. And now the trees are in front. I kind of like, well, I guess it depends on if you're looking, like if you're on this side, if this is like, I guess depends on what side of the fence you're on. But I think I like it this way. It's up to you though. But as you can see, it's so much easier to move these blocks around to rearrange the order than to move all these blocks around to rearrange the order. Right? So that's one of the benefits of using functions. It makes it a lot easier to make quick changes, big changes. Right? Bubble 5. Does it matter where you create functions? So far, all your functions have been created at the bottom of the code. What do you think will happen if we call a function before it's defined? Notice that the red square is drawn before the function is created, while the green square is drawn after the function is created. Which one do you think will be drawn? All right, go ahead and pause, read through these. You can run the program and test it out. You should find that it does not matter. Both squares will be drawn. You can create functions anywhere you like in your code. All right, it does not matter. The order calling your functions is what matters, but the order in which these are created does not matter. Or where they are in the program, it doesn't matter. All right, bubble 6. So here I asked you to do A, B, and C. Let's go ahead and start with A. My cheeks are tired from having to wear a mask all day. Okay. Also, never mind. Okay, let's continue. Calling functions, I can just get off on tangents, and I don't want to lose time on the video. So let's continue. You can call a function inside the draw loop just as you would anywhere else in your code. Do this. A function that will draw a background has been created for you. A sprite has been created to move across the screen. There it goes. Oh no, all the blurriness. Okay. Call the function inside the draw loop so that the sprite appears on top of the background. Note, don't create functions inside the draw loop, make them at the bottom of your code. All right, so we can call a function inside the draw loop, but we can't create the function in here. So let's go ahead and grab our function block. And we're going to drop it in here. Now, notice it's going to matter where we place it, okay? So we place it down here. Let's see what happens. Trees, background. We don't see our sprite, right? And that's because our background, remember, order matters. So what the computer is saying is draw the sprites first and then the background. So the background is actually covering up the sprites. So in order for us to see our sprite, we need to put this up here. That way the background doesn't cover the sprites. And there it is. Ta-da! Okay, finish. Calling functions multiple times. You often want to use the same code at many places in your program. Once you've created a function, you can call it as many times as you like. Do this. This code creates a sprite that moves across the screen once. How can you make it go back across the screen? Note, the function is already called once at the beginning of your program. Read the condition of the if statement inside the draw loop. Why do you think it's there? Use the if statement and the function written for you to make the sprite move across the screen multiple times. Okay. So basically we have our sprite that goes across the screen once, and when it gets to this side, we want it to start all over. So what is this if statement saying here? This is saying flyer, if the x position of the flyer is less than -50, right? If the x position of the flyer gets to right about over here, what do we want to happen? We want the flyer to start over again. So we need to call our setFlyer function in here. SetFlyer is going to put the flyer at x equals 450, so over here, y 200, and a velocity of -1. All right, so we're going to tell the computer, hey, once the flyer gets past this point, reset it. And set flyer. And that should do the job. We have to wait, make sure it works. It should work, but I'm going to wait. Double check. Yay, and there it goes again. Awesome. Continuing on to activity C, making changes to functions. Making changes to functions. A nice benefit of using functions to remove repeated code is that you can now easily make changes to multiple places in your code. Just change how you create the functions and your program will now use the new code everywhere your function is called. Make changes to the set flyer function so that the flyer starts at a random Y location between 0 and 400 and it moves at a random velocity every time it's reset. All right, so we need to go to our set flyer function, which is right here. And according to the instructions, we want the Y position to be a random between 0 and 400. So go ahead and change that. Random between 0 and 400 for the Y position, 0 and 400. And there's one more thing the instructions asked us to do. Set the velocity random every time. All right. So you can choose what velocity you want that to be. -1 is probably pretty slow, and maybe -6. I don't know, -8, -10. I don't know. Up to you to kind of play around and figure out what range you want to give your flyer. But notice we only had to change this inside of this function, even though that function is called multiple times in the program. We only had to change it once. And that's another benefit of using functions. You can make a change in one place and it'll apply it to the rest of your program. There it goes. Now the next time it should start at a different place, a slightly different place. It just likes that area. There you go. Goes up, goes slower. All right, so it should move up and down and the speed should be different each time. Unless it randomly selects the same speed. But there you go. You got it moving. Go ahead and click finish. Continue. I didn't have you go through activity D in class. Let's check it out, just in case anybody watching the video does need to do activity D. All right. Activity D. In GameLab, all the action is happening in the draw loop, but too much complex code is really confusing to read. Keep your draw loop easy to read. Use functions for larger chunks of code. You can call them inside the draw loop and define them below. This is a really good example of using abstraction to think about problems at a high level and worry about details later. Okay. Do this. This program should draw a daytime scene or a nighttime scene depending on the location of the mouse. The draw loop describes what needs to happen, but one of the functions hasn't been written yet. Write the draw night function, which has been created, but it's empty. Hint, look at the picture to the right for how your night image might look. Can you use the draw day function to help you at all? Okay. So basically we need to create a dark scene. So this is saying if our Y position of our mouse is greater than 200, so if it's on the bottom, if it's in the bottom half, then it should draw the night scene. Otherwise, it should draw the day scene, which is what we're seeing. So how about for our draw night, we could simply copy what we have here and then change the colors. Like that's all that really needs to happen. The colors need to change. Yeah, so let's go ahead and copy this chunk of code. You can go to text mode. Let me move my face. You can do two options. You can click and drag to highlight all of this. Control-C or Command-C. And then go here. Look for the little, move your cursor. You see this little blinking light? It's going to move around this right here. This little black line right here. So make sure that black line is right there and then Control-V. Command-V. If that didn't work, then you can go the other way, which is copy-paste your text from here. So highlight the text inside, copy it, and then I guess this would be empty. And paste it here.